That's our formula. Obviously, all I have to do is extend it, and I don't need more than 2 digits. In fact, just to have a easier way to interpret them, I just multiply them by 12 so that they're APR numbers. They're not effective annual rates. You know, we could have also made them effective annual rates. Actually, let's do that. Just for the hell of it. I'm going to say 1 plus, I'm going to divide it by 100, raised to the power minus 1, and express that as percent. The way you should read that effective annual return as, if you randomly picked a year or picked a 12-month period, you would have had on average 13% return. I thought apparently I didn't get rid of these. In fact, let me delete those. Then so you should expect a return of about 14% on smaller stocks and about 11% on larger stocks. Remember, this is 1% trim mean. If it was 0.01%, which gets us closer to the average, there is actually a big difference between the two. That's because smaller cap stocks have larger outliers. So maybe as a compromise, let's make this 0.1%. Yeah. It didn't make too much difference. Let's make it 0.5%. Because there is always a chance that you could trim too much. One of the reasons that you want to trim, you want to reduce the influence of unusual numbers. But when you think about smaller stocks, big outliers like that are not necessarily unusual, especially on the left hand. What happens to a company when they go bankrupt? Or you're owning the stock of a company, next month they go bankrupt. What's your rate of return?
You lost 100%.
Huh?
You lost 100%.
You lost 100%, so that's negative 100%. That's not necessarily an unusual number. The purpose of trimming is to limit the influence of really unusual numbers. It's kind of an art form, how much you need to trim. But here I just went with 0.5%. That means on each end, I'm getting rid of 0.25% of the data before I calculate the average of the remaining. Even there is a difference about 5% in rewards between small stocks and large stocks. Let me make that a bit bigger. And let's calculate average standard deviation, or not average standard deviation, I'm sorry, average absolute deviation, or MAD. I'm gonna do a slightly different format for that. It's kind of a measure of risk. So one thing we see, at least based on size, smaller stocks on average tend to make a lot more money, historically speaking, than larger stocks. But what do we also see? What else do we also see? Looking at those numbers. MAD is a measure of what? If I tell you that one portfolio has a higher MAD than the others, what does that mean? Huh? Deviation, but in terms of, property of an investment. Yeah, but we have a name for that. I'm gonna give you two stocks. Both are expected to have, let's say, 10% return. One of them has a MAD of 6, the other has a MAD of 12. This is the average deviation. So which one is more likely to have big swings? The one with the 6 or 12? 6. No, no. 12. No, you look at it differently, but what does that mean? If it's 12 versus 6. Okay. Yes, what is that gonna? Exactly, and we have a name for that. It's called risk, okay? I'm just trying to get you there. I know you understand it, but I'm trying to create a link between the two, all right? To understand it better, I'm sure you heard this in your stats classes. There's a little thing called empirical rule, I'm sorry. Just like a lot of things in stats, it's kind of a misnomer. There is nothing empirical about empirical rule, and it's not even a rule. Well, it's called empirical rule. If you are dealing with a population that has a normal or Gaussian distribution, aka bell-shaped curve, the chances of observing a number outside of one standard deviation from the mean is 32%, 16 on each side. Chances outside of two standard deviations, or we're going to call it sigma, that's the shorthand name for a standard deviation, is only about 5%, and outside of 3 sigma is only 0.56%. So let's consider two populations. They have the same mean. One has a, let's assume two portfolios with same expected or mean return of 10%, and one has a standard deviation of or sigma of 5% and the other 10%. I picked those numbers on purpose. What are the chances of observing a negative return? Less than 0%, okay? So population 1, 0% is 2 sigma for mean, right? We know that the chances of being outside of 2 sigma is 5%, since it's symmetrical. Using empirical rule, probability of return